Okay, in this part of our lesson, we're going to be working with writing and using a direct variation equation. So to review really quick, direct variation. In 7th grade, when we worked direct variation, it was y equals kx, where k represented a constant. We're still kind of using the same. It's just that now we're working with y-intercept equations that we'll be progressing on as we go into future lessons. So they've kind of modified this to be y equals mx, and we'll be adding on to that equation in future lessons. So they mean the same thing. Both k and m are going to be constants. It's just that m in our y-intercept equation actually represents our slope. So here is our scenario. We're going to work on some substitution. So it says the weight y of an object on Titan, one of Saturn's moons, is proportional to the weight x of the same object on Earth. An object that weighs 105 pounds on Earth, so remember Earth was represented by an x, so I'm going to actually put my x under my 105, would weigh 15 pounds on Titan, so that was our y, so I'm going to put a y right underneath that because I'm going to have to use these to substitute in. Okay, so our original equation is y equals mx. So we're going to substitute in the numbers that we know for each of those letters. So, well, our y was 15 equals m, I don't know, so I'm just going to leave it as m, but x was 105. Okay, so that's not our final equation. We need to actually figure out what m is in order to work our direct variation equation. So we're going to go ahead and get m isolated. So right now it's m times 105. We're going to divide by 105. So over here we divide by 105. Now you could go through and use the decimal, but as we start working more with slope, you're going to understand you won't understand how to graph a decimal. So it's very important to understand how to reduce that fraction instead. So if I had 15 over 105. Let's see if we know a number that would go into both of those. Well, we could try 5. For sure 5 would because they both end in a 5. But I'm going to check to see if 15 will go into 105 just to see if it'll save me a step. So if I punch in on my calculator 105 divided by 15, it gives me exactly 7. So this would become a 7 and my 15 would go into itself once. I just found out that m equals 1/7. Okay, so that's still not our final answer. Our final answer is to go through and plug in our m into this equation. So we're going to leave it as y equals 1/7 times x. There's our equation. I know, lots of work, right? What's going to end up happening is they're going to ask us some questions based on where we can substitute in for x or y, depending on the information that they give us. So letter B says, how much would a chunk of ice that weighs 3.5 pounds on Titan weigh on the Earth? So Titan, we know, was our y. So this 3.5, I'm going to put where I have y in my equation. So I have 3.5 equals 1/7 x. Now, the tricky thing on this is I have a decimal and I have a fraction involved in this equation. I prefer to work with decimals if I'm just going through and solving for something and not having to graph it. Unfortunately, if you were to do 1/7 as a decimal, it's like 0.1428 or something. 142857143, and then however many places your calculator wants to show you. So it's probably not very practical to use a decimal. Now, if you know how to use your calculator to be able to multiply and divide and isolate that 1/7 using parentheses, you could go ahead and plug it in that way because I'm not checking your multiplication and division skills. I'm checking to see if you can solve for x. So I'm going to go ahead and convert instead this to a mixed number to begin with. So that would be 3.5 equals 1/7 x. Okay. So now if I were to change that, I know that when I multiply and divide fractions, if I'm leaving them as fractions, since that 1/7 is a weird decimal, that I have to have a mixed number as an improper fraction. So I'm going to go ahead and convert that. So this would become 2 times 3 would give me 6 plus 1 would give me 7 over 2 equals 1/7 x. Okay, now I want to get x by itself, so I would divide by 1/7. Divide by 1/7. Okay, so now I have x equals 7 over 2. You guys are used to seeing it written like this when you're working with fractions, which means I'm going to keep, change, and flip. So x is going to equal 7 over 2 times 7 over 1, which becomes 49 over 2. If I take 49 and divide it by 2, it gives me 24.5. So on Earth, it's going to weigh 24.5 pounds. So that 3.5 pound object, which was a chunk of ice, on Titan is going to weigh 24.5 pounds on Earth due to the gravitational pull. Okay, so I'm going to erase this work just for now because I have another question. Okay, whoops, wrong one. Here's the other one. How much would a spacecraft that weighs 3,500 kilograms on Earth weigh on Titan? So this time they're giving me the Earth information. Okay, and remember up above, Earth was our x. Okay, so we have y equals 1/7, and then x is 3,500. So we're substituting in. Okay, this is my Earth weight, so that was my x. So that's why I put it where I have x in my equation. So this one's a little bit easier to do on your calculator because if you punch it in the way that you see it, you could punch it in as 1/7. So 1 divided by 7 times 3,500. It's doing that division by fractions, unless you understand how to do fractions on your calculator. That's kind of tricky. So if I punch in 1 divided by 7 and leave it, don't change anything, and I go times 3,500, it's going to give me 500 pounds. So a spacecraft that on Earth is 3,500 pounds, on Titan would only weigh 500 pounds.